Good evening, children.
Good evening, ma'am.
Good evening. Akiti, Swati, Bhavishya, and Randana. What about Mritika and yeah, Danya? Very good. Mritika, are you there?
Yes, ma'am.
Okay.
Ma'am,
Yeah.
ma'am, I didn't write fully, ma'am, the homework because Saturday and Sunday I went to marriage, ma'am.
Oh, you haven't completed, is it?
Son's marriage, ma'am.
So you're trying to say that you could not complete what was assigned to you?
Yes, ma'am. I am completing commutative natural numbers, ma'am, right now.
Can you finish it by the next class?
Yes, ma'am.
Okay, fine. Please do
Ma'am.
that. Yes.
Ma'am, in closure property, I haven't take for rational number. I haven't take screenshot, ma'am.
Yeah, we'll see now. Just
Okay,
stop
ma'am.
me when you need it, okay?
Okay, ma'am.
Yeah. All right, children. So I think for closure property, we need to discuss this table, right? This table, right, for closure property?
Yes, ma'am.
Yeah. Okay. So now let's sum up. Let's sum up now. Rational numbers are closed under addition. Yes or no?
Yes, ma'am.
Yes, ma'am.
What do we understand by that? Who can say? What do we understand by that? What do we understand when we say, or what do we mean when we say that rational numbers are closed under addition? What do we mean by that?
Ma'am, shall I?
Yes, Swati?
Yes, ma'am. Ma'am, when we add any two rational number, the given result is also a rational number, ma'am. So we say that it's closed under addition.
Yeah, correct. So when we add two rational numbers, any two rational numbers, when we add two rational numbers, okay, when we add two rational numbers, the sum is also a rational number, minus 7/3. The sum is also a rational number. When we add two rational numbers, the sum is also a rational number. What do we mean by? Okay, now tell me, are integers closed under addition? We'll do all the addition first. We'll do all addition first, then subtraction, then multiplication, and then division. All right. Yeah.
Yes, ma'am.
So rational numbers are closed under addition. That is, the sum of two rational numbers is also a rational number. What about integers? Are integers closed under addition?
Yes, ma'am.
That means the sum of two integers. When we add two integers, the result is also an integer. When we add two integers, the answer, whatever you get, is also an integer. What about whole numbers? When we add two whole numbers, do we get a whole number?
Yes, ma'am.
When we add two whole numbers, is the result also a whole number?
Yes, ma'am.
Yes, ma'am.
And when we add two natural numbers, the sum of two natural numbers, is that also a natural number?
Yes, ma'am.
The sum of two natural numbers is also a natural number. You can take examples. The sum of two natural numbers. The sum of two natural numbers is also a natural number. Okay. Now, are rational numbers closed under subtraction?
Yes, ma'am.
No, ma'am.
That is, when you find the difference between two rational numbers, will the result also be a rational number? So what we need to understand, rational numbers, we have more collection when compared to natural numbers, whole numbers, and integers. Rational numbers, we have more.
Ma'am,
Somebody's mic is
ma'am,
enabled. Please
ma'am,
disable your mic. Please disable your mic. Yeah. See, please remember that rational numbers, we have more collection. When compared to natural numbers and whole numbers, integers, we have more collection. When compared to all the three rational numbers, we have much more collection. When compared to natural numbers and whole numbers, in integers, we have more collection. In integers, we have more numbers than natural and whole. Now, when you take all the three natural numbers, whole numbers, and integers, in rational numbers, we have much more collection. Do we all understand that?
Yes, ma'am.
Okay, now think carefully. The thing is when you find the difference of two rational numbers, when you find the difference of two rational numbers, is the result also a rational number?
Yes, ma'am, it is.
See, because here it can also be negative. No, the convenience is here. The answer can be negative also. So if you take two rational numbers, let me take some easy ones like 3/4 and say 1/2. 1/2. Okay, we find the difference. We find the difference of these two rational numbers. 3/4 is a rational number. 1/2 is a rational number. Now the difference of these two is also a rational number. 1/4. You will get 1/4. When you find the difference, you will get 1/4. Rational numbers, we have more collection. Answer can be positive, it can be negative, it can be zero, it can be fractions. You have more collection. The difference of two rational numbers is always a rational number. So yes. Think about it, because the answer can be positive, it can be rational numbers, no? So it can be positive, negative, zero, fraction. In fraction, it can be negative, positive. So rational numbers are closed under subtraction. What about integers? Are they closed under subtraction? Is the difference of two integers always an integer?
Yes, ma'am.
Yes, ma'am.
Yes, the difference of two integers. The difference of two integers. Take any two integers like -4 and -5, two integers. Let's find their difference. Two integers. These are two integers. Let's find their difference. What's the answer? -4 plus 5, which is 1, which is also an integer. 1 is also an integer. The difference of two, this is an integer, this is an integer. The difference of two integers. Let's work that. So -4 plus 5. Answer is 1, which is also an integer. So integers are closed. Integers are closed under subtraction. So when it comes to whole numbers and natural numbers, we say that whole numbers are not closed. Whole numbers are not closed under subtraction, because if you take a smaller value first and then a greater value, supposing you take a smaller number, say 9, and then you take 20 and you find the difference. See, 9 is a whole number, 20 is a whole number. 9, so you take a difference, no? So you take a small one first and then a big one. So 9 is a whole number, 20 is a whole number, and the difference of these two whole numbers is an integer here. It's not a whole number, it's an integer, because -7 is an integer. Or you can say -7 is a rational number. So like this. Now if you take 0, 0 is a whole number. 0 is a whole number. 5 is a whole number. The difference of these two whole numbers, 0 is a whole number, 5 is a whole number. Their difference is -5. -5 is not a whole number. It's an integer. So whole numbers are not closed under subtraction. That is, the difference of two whole numbers need not always be a whole number. See, sometimes you will get a whole number as an answer. Sometimes you will get, like when you do 25 minus 5, you get 20, which is also a whole number, but not always. So whole numbers are not closed under subtraction. Same thing for natural numbers, children. Same thing for natural numbers. If you take a smaller value first and then a greater value and subtract, when you take a smaller number like 10 and then a greater number like 20, these are natural numbers, but their difference is not a natural number. Their difference is not a natural number. So they are not closed. Natural numbers are not closed under subtraction. Now, what do we understand by saying that, okay, I don't know, are rational numbers closed under multiplication? Who can explain that? Nandana, what do we mean by, if I say yes, rational numbers are closed under multiplication, how do you explain that?
Ma'am, can you ask the question again one more time? Why we say rational number is close to multiplication, ma'am?
Correct, yes.
Ma'am,
So what do we understand by that? When we say, suppose I say that rational numbers are closed under multiplication, what do you understand by that? Okay, maybe next one.
Two rational numbers will get the same answer. When we multiply two rational numbers, we get the same.
Get the same answer? Please think about that. Do we get the same answer? Okay, maybe next one you can try. Let me ask somebody else. Bhavishya, can you say that? What do you understand by that? Yeah, what do you understand by rational numbers are closed under multiplication? How do you explain that?
Ma'am, we can take any two integers in any two rational numbers, ma'am, like a and b. For that, a into b into c, and it is closed under.
Excuse me, a into b into c, yeah?
Yes, ma'am.
Take two rational numbers.
Okay, ma'am. Ma'am, I'm taking that 5 by 2 by 5 and 2 by 5, 2 into 5, ma'am.
Yeah, tell me.
2 into 5, it is 10, ma'am. So that is closed under multiplication, ma'am.
No. Okay, fine. What do we understand by that? You tell me in words, not using numbers. Tell me in words. When we say rational numbers are closed under multiplication, tell me in words, not using examples. How do you explain that? No problem. Next one, maybe you can try. Mritika. Mritika, yes.
Ma'am, rational numbers are closed under multiplication because when we multiply two numbers, we get a rational number, ma'am.
When we multiply two numbers, meaning natural whole integers, be specific. What kind of numbers will you multiply? When you multiply two?
Some rational numbers.
Okay, so when you multiply two rational numbers, yes?
We get again a rational number, ma'am.
Okay, the product we said. So the answer is called the product. On multiplying, the answer is called the product. What is the answer called when on adding? On adding, what is the answer called? The result called? Sum. Sum. When we subtract, what is the result called?
Difference.
And class, when we divide two quantities, what is the result called?
Quotient.
Quotient. Sum, difference, product, and quotient. So rational numbers are closed under multiplication means when we multiply two rational numbers, the result or the product is also a rational number. That means rational numbers are closed under multiplication. Yeah, thank you, Mritika.
Thank you, ma'am.
Rational numbers are closed under multiplication because you take any two rational numbers, you find the product. That is when you multiply them, the product is also a rational number. What about for integers? Now tell me, I asked Nandana. Nandana, now tell me,
And,
what do we mean if I say
and-
that if I say that integers are closed under multiplication? What do you understand by that?
ma'am, if two integers like we can say 3 into 2 means we get 6.
No, darling, don't take examples. What do we understand by that? Don't take examples now. What do you understand by that? Integers are closed under multiplication.
Ma'am, the answer of the two integers will get the.
What will you do with two integers? What will you do with the two integers?
Ma'am, will multiply.
Yeah, when you multiply two integers, what is the answer?
The answer should be an integer.
Yeah, the answer also should be an integer. Very good. The answer also should be an integer. When you
we multiply two integer, we will get the
Ah.
answer as the integer.
When you multiply two integers, the answer also should be an integer. That means they are closed under multiplication.
Yes.
And is it true? Are integers closed under multiplication?
Yes, ma'am.
Danya, are whole numbers closed under multiplication? Danya? What do we mean by that? Now, supposing I say yes.
Ma'am, if we subtract and
Not subtract, we are under multiplication.
I'm sorry, ma'am. We want to multiply and
What will you multiply? You will multiply what? 2?
two I don't know, ma'am. I think so. Two rational numbers.
No, what are we studying now? Here we are whole numbers multiplication.
Oh, okay, ma'am.
When we multiply two whole numbers, what do you think the result can be? Always.
Close.
Two whole numbers, 0 and 1. What's the answer? 0. 0 is a whole number, 1 is a whole number. The result is also a whole number.
Whole number.
When we multiply two whole numbers, the result is also a whole number, or the product is also a whole number.
Okay, ma'am.
So we say that whole numbers are closed under multiplication. That means when we multiply two whole numbers, the result is also a whole number, or the product is also a whole number. And again, natural numbers, when you multiply two natural numbers, like 1 into 5 or 6 into 5, when we multiply two natural numbers, the product is also a natural number. The product is also a natural number. You can take examples to understand this. So you take two. See, basically we need to understand what we are learning, meaning what do we understand by closed. So now try, Danya, try now. Now when we say natural numbers are closed under multiplication, what do you understand? When we take two?
We take two whole number into whole number, the answer is whole number.
Okay, for natural numbers?
What, ma'am?
Natural numbers.
We can multiply different numbers.
When we multiply two natural numbers, the answer is also a when we multiply two natural numbers, the answer is also a natural number. So we say that natural numbers are closed under multiplication. Now, what about for division, children? What about for division? Are rational numbers under division?
Ma'am, they are closed under division, ma'am, with the exception when the denominator is equal to 0.
Yeah, so we have to say no. Because now, supposing we take the rational number minus 4. Minus 4 is a rational number. It's an integer, it's a rational number. When you divide by 0, 0 is a rational number. Minus 4 is an integer. It is also a rational number. 0 is an integer. 0 is a whole number. It's also a rational number. This division is not defined. So just for this, when you divide this rational number by this rational number, the result is not defined. For this reason, we say that rational numbers are not closed under division. Just for this. Similarly, when you take two integers, now minus 3 is an integer, minus 4 is an integer. When you divide these two integers, minus 3 is an integer, minus 4 is an integer. When you divide these three integers, the answer is 3 by 4, which is not an integer. This is not an integer. 3 by 4 is not an integer, so they are not closed. Integers are not closed under division. Similarly, whole numbers. 4 is a whole number, 7 is a whole number. When you divide these two whole numbers, the answer is 4 by 7, which is not a whole number. So the quotient of two whole numbers is not a whole number. And same thing for natural numbers. When you divide two natural numbers, the answer need not always be a natural number. So this is how you should have completed the table. At the end of this discussion, you should be clear about what we mean by the closure property. Please fill up this table. If you have not filled, please fill it up. Just wait for a minute. Division is closed. Rational numbers are closed under division except for 0. If you remove 0 from the collection of rational numbers, if you remove 0, suppose you take away 0 from the collection of rational numbers, then rational numbers are closed under division. Please complete, children. Done, children? Finish writing, children? The table you should have made. That's why I shared all this with you the other day, because it will take time for you to construct the table, write everything, and then fill the answers. If you have not made the table, children, please take a screenshot. I'm sorry, you have to finish it later. If you have made the table, I think I gave you time to write the answers yes, no. And children, don't think that, if you're asked this question, are rational numbers closed under multiplication? You should say that answer. Just take some time. Just think about it. Just ask yourself, when I take two rational numbers, will the answer always be a rational number? Then you must also think that rational numbers have a broader collection. Fractions are there, negative numbers, positive, zero, fractions. So yes, when you multiply two rational numbers, the answer will be a rational number. For division, we say no, because when the denominator is zero, when you divide by zero, it's not defined. So they are not closed under division. All right. This is the next one. Now, commutativity or commutative property. Commutativity. Is my voice clear, children?
Yes, ma'am.
Yes, ma'am.
Okay, commutativity or commutative property. So we'll check it on whole numbers. We'll check it on whole numbers. Now first, how do we try this commutative property? Commutative means, now with respect to addition on whole numbers, with respect to addition, supposing A is a whole number and B is also a whole number, two whole numbers. If you add it in addition, no, so if you add it in any order, the answer will be the same. You can get any answer. The answer can be anything, but the answer will be the same. Don't get confused with the closure property and commutative property. In commutativity, when you add two whole numbers in any order, that is A plus B, B plus C. When you add two whole numbers in any order, the result is the same. Let me write it again. So when you consider two whole numbers, A and B, you find A plus B. You got some answer. Then you find B plus A. You will get the same answer. A plus B will be equal to B plus A. A plus B is equal to B plus A. If A and B are two whole numbers, then A plus B will be equal to B plus A. When you add two whole numbers in any order, the sum will be the same. So whole numbers are commutative under addition. Nothing. We are trying on whole numbers. Okay, so we have to take two whole numbers. That's the first thing. We have to take two whole numbers. What should you do? We are trying on the operation addition. So we have to add the two whole numbers. Now, what is this commutativity? Any order you add, you should get the same answer. That is commutativity. Any order, you perform that mathematical operation in any order, the answer should be the same. So we are trying on whole numbers, so we take two whole numbers A and B, and the operation is addition. So A plus B will always be equal to B plus A. Whole numbers are commutative under addition. Now, do you think A minus B will be equal to B minus A?
No, ma'am.
No, ma'am.
No, ma'am.
See, here it's, now you'll ask me, who are these A and B? Whole numbers. We are trying on whole numbers now. A and B are whole numbers. A is a whole number, B is a whole number. If you subtract them in any order, will you get the same answer? See here.
No, ma'am.
Now, supposing 5 and 4. When you subtract, what answer you get? Minus, sorry, 1. But when you subtract 4 and 5, you get, no. If the background is noisy, please disable your mic. Kindly do not enable your mic if there's noise in the background. So whole number, slowly, we'll do it slowly. Whole number. So two A and B are two whole numbers. Subtraction and commutative. Commutative means any order. A, B, B, A. A, B, B, A. Commutative. Subtraction. So we are trying to check if A minus B and B minus A will always be the same. And A and B are whole numbers. So if you take 5 and 4. So see here. 5 minus 4 is 1, but 4 minus 5 is minus 1. The answer is not the same. It's not that minus 1 is not a whole number, not that. The answer is not the same. The answer is not the same. 5 minus 4, the difference is 1. 4 minus 5, the difference is minus 1. The answer is not the same. So, what do you say?
Subtraction is not closed under commutative.
Whole numbers are not commutative under subtraction. Correct. Whole numbers. We'll start with that number. Whole numbers. And what's the property? Commutative. Whole numbers are not commutative under subtraction. What about multiplication, children? What about multiplication? When you multiply, we have learned no tables. 6 5s are 5 6 are. Is it the same?
Yes, ma'am.
Or if you take 0 also, because whole numbers, no? So you know that 6 5s are is the same as 5 6 are. If A and B are whole numbers, A into B is equal to B into A. When you multiply the two numbers in any order, the result is the same. The product is the same. If A and B are whole numbers, A into B is equal to B into A. Even if you take 0, 6 into 0 is 0. 0 into 6 is 0. Are whole numbers closed under division? Let's check. Now see here. Supposing, you just don't understand anything. So whole numbers, take two whole numbers A and B. Take two whole numbers A and B. So like say 6 and 10. Two whole numbers 6 and 10. Commutative meaning you divide them in any order. See, we are checking for division. So you divide in any order. That is A by B or B by A. So when you do A by B, 3 by 5. But when you do B by A, you get 5 by 3. Oh no, whole numbers are not commutative under division. 6 is a whole number, 10 is a whole number. 6 by 10 is not the same as 10 by 6. So whole numbers, any order you add, you will get the same answer. A plus B is equal to B plus A. When you take two whole numbers and you subtract them, when you find A minus B and B minus A, you will not get the same answer. The answer is not the same. So they are not commutative under subtraction. Multiplication, A into B is equal to B into A. When you multiply the two whole numbers in any order, that's what is commutativity, any order. Any order. Commutativity means any order. When you multiply two whole numbers in any order, whether you do A into B or B into A, you will get the same answer. Division. When you take two whole numbers and you divide them in any order, the answer will not be the same. So you can see addition is commutative, not is commutative, not. All right. Have you filled it? You actually have to take numbers. Numbers, that you should just take some examples.
And writing example in the numbers.
Yeah, you can write. You can fill this, or you take some examples and fill it. Let A be 4, B be 5. What is A by B? 4 by 5. What is B by A? 5 by 4. So they're not commutative under division. The space is for you to think and fill the examples, children. This space. So if you want to think by yourself later, just leave it empty now. So you can see there, A plus B is equal to B plus A. So please think about it. It's the same for natural numbers also. When you take two natural numbers and you add them in any order, you take two natural numbers. When you take two natural numbers and add them in any order, you will get the same answer. 10 plus 15 is the same as 15 plus 10. When you take two natural numbers and you add them in any order, you will get the same answer, 25, 25. But when you take two natural numbers, and subtract them in a so here you do 10 minus 15, you get minus 5. And here you do 15 minus 10, you get a positive 5. The answer is not the same. That's why not. A minus B is not the same as B minus A. When you take two natural numbers and subtract them in different orders, the answer will not be the same. Natural numbers are not commutative under subtraction. When you take two natural numbers and subtract them, first you do 10 minus 15, then you do 15 minus 10. The answer here is minus 5, the answer here is 5. The answer is not the same. So they are not commutative under subtraction. Multiplication, like whole numbers only. Multiplication, yes, they are. They are commutative. 10 into 15 is the same as 15 into 10. And like for whole numbers, here also 10 by 15 is not the same as 15 by 10. 10 by 15 is 2 by 3. That is 3 by 2. When we take, for division, I'm saying when we take two natural numbers and divide them in any order. So first we do 10 by 15 and then we do 15 by 10. In the first case, you get 2 by 3, then you get 3 by 2. The answer is not the same. So similar to whole numbers. Subtraction and division, not commutative. That means if you change the order, you will not get the same answer. Commutative is changing the order. If you change the order, you will not get the same answer. Nandana, if you're moving, if you have to move from your place for some reason, turn off your video. When your video is on, we must be presentable at our desks. If for some reason you need to get up, kindly turn off your video.
Battery charges, my laptop charges.
No problem. Whatever be the reason, children, that's okay. Just turn it off for some time and turn it on. Okay. Yeah. Yeah, I wanted somebody to explain Now when we say yeah. Now we say that natural numbers are commutative under multiplication. What do we mean by that? Who wants to try? What do we mean by that? What should we take? We should take two
Natural numbers, ma'am.
when we take two natural numbers and multiply
Ma'am,
them
the
in
sum of two natural number is a natural number.
Ma'am, the product of two natural numbers is always a natural number, ma'am.
that is closure property. This is commutativity. When you take two natural numbers and multiply them in any order, whether you do A into B or B into A, the result is the same in both the cases. The product of two natural numbers is always a natural number, is closure property. Natural numbers are closed under multiplication. This is commutativity.
Yes, ma'am, we do it in two different methods and the answer should be same.
Yeah, different or yeah. When you multiply two natural numbers in any order, the answer is the same. Not that the answer is also a natural number, not that. That is closure property. The answer will be the same in both the cases. When you take two natural numbers and multiply them in any order, the answer is the same in both the cases. But when you take two natural numbers and divide them in any order, when you do A by B and B by A, the answer will not be the same.
And the order matters here.
Correct. The order matters here. A by B, answer is not the same as B by A. Integers, children. Commutativity on integers. So I'll just give you examples now. See here. So when you take two integers, -4 is an integer, -10 is an integer. The answer is -14. -10 plus -4 is -14. So it is commutative. Subtraction, addition is commutative. Subtraction, same example I'll take. -4. Disable your mic, children. I'm taking the same example, -4, -10, I'm subtracting. -10 minus -4. See here, I've taken two integers. -4 is an integer, -10 is an integer. I'm subtracting the two integers. In this order first and then in this order. I'm taking -10 first, then -4 and I'm subtracting. When I subtract in this order, I get -4 plus 10, which is 6. When I subtract in this order, I get -10 plus 4, which is -6. We don't get the same result in both. I considered two integers, -4 and -10. I subtracted them in different orders. In the first method, I got 6 as the result, while in the second, I get -6 as the result. The results are not the same. Hence, integers are not commutative under subtraction. I'll take the same two integers, -4 and -10, and I'll multiply them in different orders. And I'll check the result. I get 40 here plus 40. I get plus 40 here. The answer is the same. That means integers are commutative under multiplication, or multiplication is commutative. I'll take the same two integers and I'll divide them in different orders. First I divide like this, then I divide by like this. And here minus gets cancelled. The result is 2 by 5. While here also minus gets cancelled, but the result is 5 by 2. The answer is not the same in both the cases. So division is not commutative. So when you change the order using integers, when you change the order matters here. For addition and multiplication, it's okay. For subtraction and division, it's not okay. So commutativity, when we consider two integers and perform the mathematical operation in any order, the answer should be the same. If it is the same, it is commutative. Otherwise, it's not commutative. You can see we have taken the integers -4 and -10. We added, we subtracted, multiplied, and divided in different orders. That is AB, BA. First AB, then we change the order BA. In addition and multiplication, we get the same answer. But in subtraction and division, we get different results. So commutativity is changing the order. So you can see here. Addition is commutative for integers, subtraction no, multiplication yes, division no. Somebody tell me, what do we understand by, if I say rational numbers are commutative under addition, what do we mean by that? Okay, A by B is a rational number. I can even say A is a rational number, but supposing I say I have two rational numbers, A by B and C by D. Use this and tell me. Commutativity means what? Adding them in. Yes, Swati?
When adding rational numbers in different orders and with the same number.
Correct. So use this as example and say, Nandana, A by B, C by D. Nandana, there's a lot of noise. I can say to your mic.
Shall I?
Put in the chat,
Ma'am, ma'am, it's like A by B plus C by D, ma'am. The answer is same as C by D plus A by B, ma'am. While adding to rational number in any order, the answer remains the same, ma'am.
Perfect. Yes. So when we take two rational numbers, so when you take the rational numbers like 4 by 5 and say 16 by 5. 4 by 5 and 16 by 5 are two rational numbers. We add them. 4 by 5 and 16 by 5 are two rational numbers. See, I'm taking the same denominator for the sake of convenience, children. Otherwise, we'll have to take the LCM and then add, just so that we save time. 4 by 5 is a rational number. 16 by 5 is a rational number. When we add them, we get 20 by 5, right? And the answer is 4. When you add them in a different order, 16 by 5 first and then 4 by 5, still we get the same answer, 20 by 5, which is 4. So addition is commutative on rational numbers. When we take two rational numbers and add them in different orders, the sum will be the same in both the cases. A by B. So I said A by B plus C by D, right? So when you have two rational numbers A by B and C by D, when you perform A by B plus C by D and perform C by D plus A by B, the answer is the same in both the cases. When we subtract, if you take the same example, 4 by 5 and 16 by 5, when we subtract 16 by 5 and 4 by 5, when we subtract, here we get minus 12 by 5, while here we get 12 by 5. The answer is not the same. So they are not commutative under subtraction. You get different when you change the order. First one minus the second one. Second one minus the first one. Different answers. Commutative. First minus second, second minus first. Same answer, no different answer. So they're not commutative under subtraction. But for addition, the first rational number plus the second rational number, the answer is the same as the second rational number plus the first rational number. Similarly, multiplication was also true. When you take two, rational numbers 4 by 5 and 16 by 5, their product 64 by 25, because 4 16s are 20. Here for multiplication, you should not take LCM. For multiplication, you should not take LCM. Multiply the numerators, multiply the denominators. 4 into 16 is 64, 5 5s are 25. When you do 16 by 5 into 4 by 5, also you get 64s are 64 by 5 5s are 25. Get the same answer. Rational numbers are commutative under multiplication. Rational numbers meaning integer by integer. When you take two rational numbers and multiply them in any order, first number multiplied by the second number multiplied by the first number. Answer is the same in both the cases. So rational numbers are commutative under subtraction. First, you should mention the number. There are three things here. The number, that is whole number, natural number, whatever number. The number, then the property, commutative, then the operation, mathematical operation. Rational numbers are commutative under multiplication. So there are three parts in this statement. Rational numbers is the number we are talking about. The property is commutativity. So rational numbers are commutative. And then the mathematical operation under multiplication. Division, as we understand, is not commutative. So like 4 by 5 divided by 16 by 5. And let's work this. So how do we work this, children? How do we work this?
We need to take the reciprocal of the divisor, ma'am.
Yeah, we need to take the reciprocal here of the second fraction. So division becomes multiplication. 16 by 5 becomes 5 by 16. So the answer is 1 by 4. But when we perform, are we all there? Bhavishya, Danya, Ritika, Swati, Nandana, are we all following?
Yes, ma'am.
Yes, ma'am.
Okay, what are the two, Bhavishya, what are the two rational numbers we have taken up? Bhavishya,
Ma'am.
what are the two rational numbers we have taken up? Danya, what are the two rational numbers? What are the two rational numbers we have taken up? No, Danya, you need to unmute and say. Is that a difficult question? And Danya, is that a difficult question? Ritika, what are the two rational numbers we have taken up?
Ma'am, I can't understand your question, ma'am.
What are the two rational numbers we have taken to check for division?
Ma'am, 4 by 5 and 16 by 5, ma'am.
16 by 5, 4 by 5 and 16 by 5. Okay. What do we get? How do we work? Ritika, how do we work 4 by 5 divided by 16 by 5? Is equal to?
Ma'am, we should divide
So just tell me
16.
what I should. what should I write? 4 by 5?
Ma'am?
Yeah, no, just tell me what should I write here? 4 by 5? How do I
Divided by.
calculation? No, division must be
Ma'am.
written as?
Ma'am, we should cross multiply, ma'am. Ma'am, we should cut 5 and 5 and divide 4 and 16, ma'am.
Okay, so how do you present it? So we write the first fraction as it is. Then the division becomes multiplication. We take the reciprocal of the second fraction, 5 by 16. Write the first fraction. This is a trend. Write this one as it is, 4 by 5. Division, whenever it's division, you change it to a product. Division becomes multiplication, and the second fraction must be written as its reciprocal, 5 by 16. Four by 5 divided by 16 by 5.
16.
Is it? Yeah, right. 4 by 5 as it is. Division becomes
Reciprocal of
multiplication.
16 by 5, ma'am.
Is what is the reciprocal of 16 by 5?
5 by 16, ma'am. And now we should cancel 5 and 5, ma'am.
Then 4 ones are 4 fours are.
4 and yes, ma'am. And 1 by 4 is the answer.
Okay, now change the order and divide. That is right, 16 by 5 first.
16 by 5, by 4 by 5. And then we should take we should write 16 by 5 and take the reciprocal of 4 by 5, ma'am. That is equal to.
Should I write division here?
No, ma'am, multiplication symbol.
Multiplication. 4 by 5 becomes?
5 by 4, ma'am.
Okay, then?
Now we should again cancel 5 and 5, ma'am.
Okay.
And if you're doing 16 by 4, now we should again go in that table, ma'am. So 4 will be changed into 1 and it will be changed as 4, ma'am. So now the answer is not equal, ma'am, because here goes for 4 by 1, ma'am. And that's 1 by 4, ma'am.
Yeah, so here the answer is 1 by 4. When we change the order, the answer is 4. So tell me the statement, what do you say? So what is your conclusion about commutativity on rational numbers for division?
And in division, rational numbers are not commutative under division, ma'am.
Under division. Rational numbers are not commutative under division.
Yes, ma'am.
All right.
Thank you.
Yeah. So like this, you can take any two examples, any two numbers, any two rational numbers. If you want to take down this, you can take down. I want you to check with your own numbers. If you want to take down, please take down.
Finished, ma'am.
Yeah. Children. So the same thing. So see, when we change the order, even if they are rational numbers, when we change the order, we get the same answer for addition and multiplication, but not for subtraction and division. So basically, commutative property, what we have seen is commutative property, whether it is rational, integers, whole numbers or natural numbers, for addition everywhere it works. When you change the order and add, whatever numbers they are, when you change the number, when you change the order and add, the answer is the same. When you change the order and multiply, the answer is the same. But when you change the order and subtract, you don't get the same answer. Whatever be the number, meaning whether they are rational, integers, whole or natural. When you change the order and subtract or divide, we don't get the same result. I'll write it again. I said whether they are rational numbers, integers, whole numbers or natural numbers. Commutative property is basically changing the order. Changing the order. So whether they are rational numbers, integers, whole numbers or natural numbers, when you change the order and add, you will get the same answer. When A plus B, B plus A is the same. It's the same. When you change the order and multiply, the answer is the same. But when you change the order and subtract, when you subtract by changing the order, you do A minus B and then B minus A. No, we don't get the same answer. We don't get the same answer. Similarly, when you change, when you perform A by B and then B by A, the answer is not the same. The answer is different. Now associativity. So we saw closure property. We saw closure property. Closure means, now supposing we try on addition. When we take two natural numbers and add, the answer also should be a natural number. That is closure. Commutative is changing the order, A, B, B, A. Associativity. For associativity, you need to take three numbers. Three numbers. Associativity, you need to take three numbers. Now, here we talk about whole numbers. So when we take whole numbers A, B, and C, supposing you first add A and B. For associativity, we need to take three numbers. Three numbers. So now when we take three numbers A, B, and C, supposing you first add A and B, and then that result if you add to C, it will be the same as you add B and C first and then add the result to A. That is when you group the numbers in any order, the sum is the same. When you group the numbers, when we have three numbers, three whole numbers, and we group them in any order and find their sum, the sum will be the same. Now let's try for subtraction. Whole numbers, say, we take whole numbers, say 5, 0, and say 3. So we'll first group this one like this, children. You can, I think I'll use less words and more of writing. We need to check this one. Is it always the same? Oh, I wrote the same thing. Sorry. I wrote the same thing. I'm sorry. And then change the bracket. Yeah. You can understand from the way it is written, children. The three whole numbers are 5, 0, and 3. I have taken three whole numbers, 5, 0, and 3. You can take any three whole numbers. I have taken 5, 0, and 3. So in both I've written 5, 0, 3. But the bracket, you see, in the first case, I've used the bracket for 5 and 0. In the second case, I've used it for, okay, in the first case, I've used it for the first two numbers. And in the second, I've used it for the last two numbers. Do we get the same answer? Check the answers. I'll just write it again. There's no place for me to write the answer. Just write the same thing again. Just writing the same thing. I said 5, 0, and 3. So I wrote 5. See the way we write it, 5, 0, and 3, children. Okay, subtraction. Subtraction. Put the bracket for the first two. Last two. Is the answer the same? What's the answer in the first case? We must first simplify the bracket. We need to first simplify the bracket. See, what is the difference? We have taken three whole numbers, 5, 0, and 3. First, we subtract 5 and 0, and then minus 3. Here, I've used the bracket. Here, I've used the bracket for the first two numbers. Here, I've used the bracket for the last two numbers. Like this, when we find the difference, is it the same? Do we get the same answer in both the cases?
No, ma'am, we will not get the same answer.
So here it is. We have to first work the bracket. 5 minus 0 is 5 minus 3, which is 2. Here, this answer for the bracket 0 minus 3. Here 5 minus 0 minus 3 is minus 3, which is 5 plus 3, 8. See here, this one is 5. The answer is 5. So 5 minus 3, 2. Here what happens? I've written this 5 as it is. We need to simplify the bracket first. This minus as it is. In the bracket 0 minus 3 is minus 3. 0 minus 3 is minus 3. And when you open the bracket, minus into minus is plus. When you open the bracket, minus into minus is plus. So 5 plus 3, 8. 2, 8. So whole numbers are not associative under subtraction. If you group them in different orders, we don't get the same answer. Whole numbers, when you group them in the grouping, you're grouping. First I grouped 5 and 0. Then I grouped 0 and 3. When I group them in different orders and use the operation subtraction, I don't get the same answer. This answer is 5. This one is 5 minus 3, which is 2. Here 5 minus I've written as it is. 0 minus 3 is minus 3. And minus into minus is plus. Open the bracket. So 5 plus 3, 8. So here I get 2, here 8, not the same answer. So whole numbers are not associative under subtraction. Okay, so see here, A, B, C are three numbers. A, B, C are three numbers. When you multiply them in any order, the product will be the same. A, B, C. When you multiply, supposing you do A, B first, and here you do B and C first, you will get the same answer in both. When you consider three whole numbers and you group them in different orders and multiply, you will get the same answer. But again, that will not work for division. That will not work for division. Supposing you take 2, 4, 6. First you divide 2 divided by 4 and then you divide by 6. Same numbers 2, 4, 6. If you do this, you will get different results. How to solve all this we'll see later, children, because now we'll just understand the property. How to solve this we'll see later. When you take three whole numbers and group them in different orders and divide, you will not get the same answer. You will not get the same answer. Okay, let me do it. So how do you write this one? I'll just work it here. I'm just working it here. The division, I'm working it here. Okay, I'm just working it here. So there's nothing but 2 divided by 4 divided by 6. When I'm working, look at the screen. So this is 2 divided by 4 divided by 6. So that means 2 by 4 into 1 by 6. So 2 ones are 2 threes are. The answer is 1 by 12. Now when we do 2 divided by 6 like this. How do we work this? This is 2 divided by 4 by 6. 4 by 6. So that means 2 into 6 by 4. So 2 ones are 2 twos are 6 by 2, which is 3. The answer is 3. Let's solve this again. So 2 divided by 4 divided by 6. 2 divided by 4 divided by 6. How do we do this? Here it is 2 by 4 divided by 6. So 2 by 4 into 1 by 6. 2 ones are 2 twos are 1 by 12. Multiply the numerators, multiply the denominators, 1 by 12. Here it is 2 divided by 4 by 6. So 2 into 6 by 4. Division becomes multiplication, reciprocal. 2 ones are 2 twos are. 6 by 2 is 3. The answer is not the same. When we group three whole numbers in different orders and perform this mathematical operation division, the answer is not the same in both the cases. When we take three whole numbers, group them in different orders and to divide, the answer is not the same. So whole numbers are not associative under division. Whole numbers are not associative under division. So this again becomes Addition, you group them in any order and add, you will get the same answer. Subtraction, if you change the order, you will not get the same answer. Multiplication, you will get the same answer. Division, you will not get. See, for associativity, you need to use three numbers A, B, C. A, B, C. You need to use three numbers A, B, C. You need to group A and B and then B and C. You're grouping in a different order and you're performing the mathematical operations. Associativity, we need to take three numbers, group them in different orders and perform the mathematical operations. So when you change the order, addition works, meaning you'll get the same answer. Subtraction will not yield the same answer in both the case. Multiplication, yes. Division, no. That's what you see here. See here, when you take three numbers and you group them in a different order, you group B and C, you group A and B, and you add, you'll get the same answer. But when you do the same thing with subtraction, you will not get the same answer. Multiplication, you get the same answer. Division, you don't get the same answer. Same thing, children. I'll just write C because now you know how to apply the property. So now associativity means three natural numbers you must take and add the first two, add the last two like this, group it in a different order. You will see that addition is associative, subtraction is not. Same thing like the earlier one, like same as for whole numbers. Multiplication, yes. Division, no. For subtraction and division, when you group in different orders, the answer will not be the same. You'll get different answers. Addition, yes. Multiplication, yes. Subtraction, no. Division, no. Three natural numbers grouped in different ways. Same thing holds for integers because we'll be checking the properties. So there you will see it. When we get into the exercise and we check the properties, you will see how to calculate. So now we have understood what associativity means. How many numbers should you consider for associativity?
Three numbers, ma'am.
Three numbers. Three numbers. For associativity, you must take three numbers. And you should group them in different ways. In the first case, you should group the first two numbers. And the second case, the last two numbers. So like A, B, C, you should first do A plus B and then plus C. You must do B plus C and then add that result to A. Using the bracket in different ways. Grouping in different ways. So here also, it works for addition. It does not work for subtraction. It works for multiplication. It does not work for division. So you can see here, when you take three integers, you group them like this, same answer. Subtraction, no. Multiplication, yes. Division, no. Again, associativity, rational numbers. So when you take three rational numbers, so supposing I say A by B, C by D, E by F, you can say three rational numbers A, B, C also, children. That's also fine. You can say three rational numbers A, B, C. That is, we are calling 4 by 5 as A. That's all. See, you can say A, B, C also. See, because like you can say let 4 by, meaning A be 4 by 5, let B be minus 2 by 3, let C be minus whatever, like this. You can say let the three numbers, rational numbers be A, B, C, or you can say let one be A by B, the other one be C by D, E by F. This is also fine. It's not that if it is rational number, this is only correct. This is fine. This is also fine. Let A, B, and C be three rational numbers. Or you can say let the three rational numbers be A by B, C by D, E by F. That's also fine. So when you take three rational numbers, and you group them in different orders. So here you group it like this and add. Here, oh sorry, C by, oh my God, I'm sorry. A by B, C by D, E by F. A by B, C by D, E by F. Add. I group the first two, I group the last two. I'll get the same answer. But here, when I do this, I'll not get the same answer. We'll get different answers. When I multiply A by B into C by D into E by F, I group the first two. A by B, C by D, E by F. Multiply by grouping the last two here. I will get the same answer. The answer will be the same in both the cases. But when I take three numbers A by B, C by D, and E by F, and I divide the first two and then with the last one, A by B, C by D, E by F, all division. But you group it like this. That means you perform this one first and then with A by B. The answer will not be the same. We'll be verifying these properties. So associativity means taking three numbers. So rational numbers, associativity, we take three rational numbers. And when we group them in different orders, we group the first two, we group the last two. On adding and multiplying, you'll get the same answer. On subtracting and dividing, you will not get the same answer. Rational numbers are associative under addition and multiplication, but not under subtraction and division. Rational numbers are associative under addition and multiplication, but not under subtraction and division. If you group first and two and then the first and second and then the last two, the second and third, and you perform these mathematical operations, it will work only for addition and multiplication, not for subtraction and division. You will get different answers. What you see is, I'll show you all the three slides now. This is summing up for associative property. Let me clear the slides 1 minute. Naturally. So sometimes it may be difficult. See, what we've been doing is we when I keep repeating the terms and whatever we're doing, something is understood now. Now when your teacher again does it in school, maybe things will become very clear. And this chapter, according to me, it's not very appropriate to start off, but schools will start off with this chapter first, rational numbers. So I was forced to. So I've been talking a lot in the first in these two sessions, the first and second. So next session onwards, you will be put to work. So it's rational numbers sounds more like a theory class. Maths looks very theoretical, not practical, but it's not so. From the next class, you will definitely get to work. All right, children. So let's fill this table. So just for you to, remember easily, I'm telling you this. Everywhere, see, associative for everything. Addition, for addition everywhere, yes. For multiplication, everywhere, yes. For subtraction and division, no. For subtraction and division, no. See, I'm not telling you this without explaining. Now you know how to check. Associative property, whatever be the number, rational, integer, whole number, natural number, whatever be it, for all the four, associative property holds good for addition and multiplication. Associative property holds good for addition and multiplication, not for subtraction and division. Whatever be the numbers, whatever be, for addition and subtraction, it's always yes. Oh, addition and multiplication, it's always yes. For subtraction and division, it's always no. Associative property holds good for addition, always. Addition, always. Multiplication, always. Subtraction and division, no. Subtraction and division, no. Please fill this. Addition, multiplication, yes. Subtraction, division, no. Commutativity. Same thing. Commutativity also similar to associativity. Commutativity also similar to associativity. Addition, always yes. Addition, always yes. If you change the order, you'll get the same answer. Addition, multiplication, always yes. Subtraction and division, always no. When you change the order, commutative, A plus B, B plus A. A minus B, B minus A. That is commutativity. First AB and then BA. First AB and then BA. For addition and multiplication, you will always get the same answer, but for subtraction and division, the answer will change. It's not always the same. So I showed you the final table for associativity and the final table for commutativity is the same. The final table for associativity and commutativity is the same. In both associativity and commutativity, it works for addition and multiplication, but not for subtraction and division. Now, Nandana, what are the three properties of rational numbers?
Ma'am, I think
Yes, yes, Danya, tell me.
commutative property, closure property, and associative property.
Associative property. Very good, Danya.
Ma'am.
Good.
And can you hear me now?
Yes, Nandana, repeat. Name the what are the three
Ma'am.
properties of rational numbers?
Closure property, commutative property, associative property. Ma'am.
Very good. For us to check associative property, how many numbers will you consider?
2 numbers. Ma'am, 3 numbers. 3 numbers.
3 numbers.
Yes.
For commutative, how many numbers?
Commutative only 2 numbers.
2 numbers. Okay. And when you see the final table for closure property, the final table for closure property, here little careful we have to be, okay? A little careful. Here also it's closed. Addition, it's always closed. Addition is always closed. Tell me, guess what's the other thing for multiplication?
It's always yes, ma'am.
It's always yes for multiplication. So what do we observe? In all the 3 tables, where we sum up the results, whether it's the closure property or associative or the commutative property, in all the 3 final tables, addition and multiplication is always yes. Addition multiplication is in all the 3 tables. Closure, associativity, commutativity, in all the 3 final tables, what we see is addition, multiplication, always yes. Subtraction and division always no, but only in closure. Only in closure. See here. Addition, multiplication, yes. Subtraction, division, no, in all the 3 tables, but in closure, division, but subtraction alone, it works for rational numbers and integers, but not for whole numbers and natural numbers. We have already taken examples and understood, children. I'm not going to give you examples again. You can just remember like this. We have discussed. You can just remember like this. All the 3 tables, addition is yes, multiplication is yes. All the 3 final tables. Division in all the tables, no. Subtraction in all the tables, no. But in this closure property, only for rational numbers.
For rational numbers and integers is yes.
Yes.
Ma'am, because of vast collection.
Correct. Just remember like this, children. See, if you don't understand anything and you just remember yes, yes, no, no, that's not the right way. But now we have taken some examples and we try to understand something. So now it's better you remember like this so that you can write the answer in the exam. Now, for the sake of exam, you'll have to remember something, right? You cannot spend 2-3 minutes checking. Then you might not complete the paper. You might miss out on answering some question. Once you understand, you should try to remember using some trick. Without understanding, if you memorize this table, yes, yes, no, no, that's not right. But now we have taken examples. We have seen what is meant by closure, associativity, commutativity. So now it's okay to remember like this. You can remember like this. I'm repeating it. Everywhere, yes for addition, all the 3 tables, yes for addition and multiplication, no for division in all the 3 tables. This is also no, only in closure property, only for closure it is yes. The other two tables, no. Everywhere it is no. Only these two, yes, in closure table. Rational numbers and integers. All right, children, I think I've taken a little more time of yours. Yes.
Ma'am, please show me the rational numbers and closure property, ma'am.
Yeah. Let me just stop the recording and I'll show you. Yeah, sure. Children, all of you take pictures of your classwork and share it on WhatsApp with me. Finish your dinner and do it today. Tomorrow I will not consider as submission. Today, finish your dinner. Take pictures of your classwork book, not your school classwork notebook. Now what we did in last class and this class. Take pictures and share it on WhatsApp with me.
Okay, ma'am.
All right, children. Thank you so much. That's it for today's session. Good night.
Thank you, ma'am.
Thank you. Good night.
Ma'am, show me.
Yeah. I'm not leaving the meeting. I'll just stop the recording and show you.